767 is powered by two GE CF6-80C2 engines. These engines are extremely reliable and have also been used on aircraft such as the DC-10, A300, and L-1011. Each engine has a takeoff thrust rating as shown above. You can click on the Info button to view information from GE's website. The engines are dual-rotor axial flow turbofans of high compression and bypass ratio. The rotor assemblies, N1 and N2, are mounted on concentric shafts. The N1 consists of the fan and a low-pressure compressor and turbine section on a common shaft. The N2 consists of the high-pressure compressor and turbine section on a common shaft. The N1 and N2 rotors are mechanically independent. The N2 rotor drives the engine accessories and is mechanically connected to the accessory drive. Therefore, the pneumatic starter is connected to the N2. Each engine is equipped with a pneumatically operated thrust reverser. The thrust reversers are used to reverse the fan airflow during ground operation to aid in deceleration. The flight deck controls associated with the engines are shown here. We'll provide an overview of these controls on the following frames, but more specific information is provided in other CBT modules. The fuel control switches are moved to run during engine start and are moved to cut off when the pilot shuts down the engine. Each fuel control switch has a red light that will illuminate if an engine fire is detected. Amber lights above these switches provide indication of the fuel valves on each engine. The thrust levers are moved to select a thrust level. The thrust levers are normally positioned by the auto throttles, but can be manually positioned by the pilot at any time. With the thrust levers in the idle position, the thrust reverse levers may be raised by the pilot to deploy the thrust reversers when the aircraft is on the ground. The Thrust Mode Select Panel, or TMSP, may be used to manually select the maximum thrust reference mode for various flight conditions. It can also be used to select reduced thrust levels. However, the thrust reference modes are normally provided by the FMS. Note, the TMSP is not often used on some aircraft, as thrust mode selections are automatically performed by AFDS mode changes, so that pressing buttons on the TMSP is not necessary. The start and ignition panel has 3 knobs and 2 lights. There is one start switch for each engine. The available switch positions provide various levels of ignition operation, and the ground position provides engine starter control. The ignition selector is used to select single or dual ignition for both engines. The valve lights illuminate when the engine start valve is in transit or is not in the commanded position. Each engine is controlled by an electronic engine control, or EEC, sometimes called a FADEC. The EECs monitor thrust lever position and then set commanded thrust. The EECs also provide protection from exceeding maximum thrust limits. The EECs are required for engine operation and are self-powered when the engine is running. If an EEC fails, the engine will shut down. The electronic engine control switches are normally in the on position. Pressing a switch will select the engine EEC to the alternate mode. Engine indications are normally displayed on the two ICAS displays, which are available when normal power is on the aircraft. The primary engine indications display on the upper screen and are always displayed. The lower screen can be blanked, or can display aircraft status, or can display the secondary engine indications. Here we show the secondary engine indications. Some indications are provided with moving dial pointers and boxed digital readouts. Other indications display with a vertical scale, moving pointers, and boxed digital readouts. We'll learn more about these in the Controls and Indicators module. The Standby Engine Indicator, or SEI, is normally blank, but will automatically display data when both ICAS displays are failed. This indicator provides indications that would be especially valuable after a dual engine failure, since the ICAS will blank when normal power has failed. Now, let's answer some questions about what we have learned in this module.